Hey guys, Hayden here again from Alarm System Store, and today we're going to be going over Honeywell Vista wiring. So basically, we do have a video for this on our channel, which I'm going to link below. It's more of a demo style video, however, and I kind of wanted to get into the more technical aspect of the wiring, like what you connect to each terminal. The demo kind of shows some of that. However, it doesn't go very in depth on the more intricate things like wireless receivers, zone expanders, how you would connect a relay module, that kind of stuff. So essentially what this video is about is just the Honeywell Vista basic wiring. We're going to be going over all the terminals, and I have a diagram which should come on all Vista control panel, the doors for the cabinet. But this diagram basically gives you a full layout of what each of the terminals is, what you connect to them, what it can do, so on and so forth. And in today's video, I just kind of wanted to go a little bit more in depth on that. If you guys are looking for more of a demo style video where you can just see a few sensors hooked up and like where you plug your keypads in, you know, the more simple stuff, by all means check out the other video down below. But if you want to know a little bit more about what you're actually connecting to what, this video is going to cover that. And if you guys are looking for a Honeywell Vista system, or if you're interested in DSC or QualSys, we have all three of those brand systems on our website. We don't carry into the Honeywell wireless systems, but if you need a Vista, we do have that. We got the 15P and the 20P. We have the QualSys IQ Panel 4s, the hubs, and the IQ4NS, as well as the DSC Neo line. So if you have any interest in any of those panels whatsoever, or if you're looking for service for said panels, you can head on over to alarmsystemstore.com. You can find all the info you need there. You can also reach out to us if you have any questions. All right, so give me just 1 second. I'll get the camera moved over here and we will get started. All right, guys, so I have our system here. It's just sitting in the cabinet door. Don't ever have your main board, if you do take it out of the cabinet, don't ever have it sitting directly on metal if it's powered up. Right now, everything's depowered so that I can visually show you guys what I'm doing. But essentially, like I mentioned, we're just going to be going over the more technical aspect of the wiring for this system, the Honeywell Vista. This applies to the 15P, the 20P, the 10P even. So essentially, like I said, this cabinet, all of them should come with this large sticker, which actually is the wiring diagram for the system. You can find the exact same thing. I believe it's on the last page of the installation manual, but it just gives you a terminal by terminal explanation of what everything does. And now, a lot of the stuff, if you're just reading it offhand, won't make sense to you, especially if you're a DIYer and you haven't worked with a Honeywell before, or if you're just getting into the industry and you're not used to them. So, essentially, like I said, we're just going to be going left to right. I'm going to explain what each of the terminals is, what you can connect to it, and the more technical side of it, like for bell circuits, for example. You can have up to 2 amps worth of power being pulled from the bell circuit on the panel. By default, it says in the manual that you get 600 milliamps. There's a reason why you actually get 2 amps instead of the 600 milliamps, and that's the kind of stuff we're going to be covering. So, the 2 first terminals over here on the left are for your AC input. Honeywell systems take a 16-volt AC input, generally somewhere between 25 to 50 volt amps. You have a transformer that's plugged into a wall, and it's going to have a 2-wire connection that connects to the 2 left terminals on your Honeywell Vista board. Those do not have polarity because it is alternating current. Once it hits the board though, it converts that to DC 12-volt power. So after that, you do have to pay attention to polarity when you're connecting bells, sirens, keypads, motion detectors, things like that. But for those first 2 terminals, there's no polarity. Just make sure that your transformer has a 2-wire connection like this one. So you have AC and AC, and there is a ground which you can use to ground the panel to if you wish, but essentially you just need these 2 wires which are going to connect to the AC terminals, and those two are going to connect to these left two terminals on the board. Now, moving on from there, this is where it gets a little hairy because Terminal 3 has one specific job, but Terminal 4 is the ground for all devices that you're going to connect to the panel. So Terminal 4 on a Honeywell, if you have a larger system, can get really messy. It gets really full of wires, and if you're not careful, they will actually just start slipping out because it can't contain the amount of devices that you have powered on your system. At Alarm System Store, we offer a device like this, which is called a DT600, and what this does is it's just basically a fancy wire splitter. You have two terminals on the top here, the left and right ones. You plug wires into them. Generally, you'll have a red power side, and then you'll have a negative black ground side, and basically it just splits those right down the middle. So you'll have a whole side where you can connect power, and then you'll have a whole side where you can connect the ground for each of your modules, motion sensor power devices, anything you need. So these kind of devices are really handy to have on a Honeywell. If you don't have a device like this, or you don't want to purchase one, you can use B connectors or wire nuts if you want. I don't usually recommend wire nuts for alarm system wiring just because it is usually a small gauge. Most people use 22 gauge. So if you're using wire nuts, they can slip out of there, especially if you don't get it tight enough, if you don't get it all snug, the whole bit, which is why I kind of like this, because it gives you an individual connection for each wire that you need to plug in, and each one has its own screw to tighten it down, so you can at any time come and just check the wiring, make sure it's all snug, make sure it's all good. However, moving back to the board itself, terminal number 3 here is actually the positive bell terminal. So that is where you're gonna connect the positive side of any siren that you're gonna have on the Honeywell Vista. That output is rated for up to 2 amps, like I mentioned. What that means is while the system has battery power, which is what these 2 wires are for, they connect to a backup battery, the system, when it goes into alarm, it will pull power from that battery to jump that bell circuit up to a total of 2 amps. So by default, like I mentioned, you would normally have 600 milliamps of power. For anything that's not an alarm, the system is going to have that 600 milliamp limit. But like I mentioned, if you need more siren power, you do get up to 2 amps when the system's in alarm. So any sirens are going to be connected, any sirens are going to have their power wire, generally red, connected to the number 3 terminal here. Now, like I said, number 4 is where things get messy, and I don't know how well you guys are going to be able to see it there, but essentially, terminal number 4 has 3 different lines coming off of it with a bunch of notes talking about all the different stuff it does, and that's because that is the main ground for the panel. That is going to be your black wire for your sirens, for your keypads, for your powered devices, motions, glass breaks, whatever. They're all going to be connected to terminal 4 to ground them to the panel. So that one's pretty simple. There's not much to really go over. However, just know that terminal 4 is also where the CORBUS for the system starts, or keybus, depending on when you started in the business. But essentially, the CORBUS is the main 4 terminals where your modules are going to connect. So that's going to be keypads, zone expanders, relay modules, usually communicators, wireless receivers. I think that's all at the moment, but essentially all of those devices are going to be connected to terminals 4, 5, 6, and 7. So to go over those a little bit more in depth, like I mentioned, 4 is going to be the ground for those. 5 is the power, the main power output for the panel. That's where your modules are going to get power. That's where your powered devices like motions and glass breaks are going to get their power as well. So terminal 5 can get almost as messy as terminal 4. That's another terminal where it's handy to have something like this, where you can actually split that power off into a few different terminals to give you more space. Moving on from there, terminal number 6 is your green data in cable from your modules. So, like I said, all modules are going to have a 4-wire connection. It's usually black, red, green, and yellow. Now, we've covered the black and red. Green is going to connect to terminal 6. So, your keypad green, your wireless receiver green, zone expander green, they're all going to connect to terminal 6. And that is where the panel receives the data from those modules at. So if you ever see, like on a keypad, if you don't have the data wires connected properly, it'll actually say open circuit on the keypad. And what that means is it's getting power because it's powered up and you can see the screen coming on, but it's not receiving any data from those modules. So it's either the green or the yellow wires that you're having an issue with. But I digress. Terminals 6 and 7 are your data in and out. 6 is the data in, and 7 is the yellow data out cable. That's where all of the information that the panel sends to the modules goes out from. So those 4 terminals right there are, like I mentioned, the CORBUS of the system. Those are the 4 core terminals that you're going to use for your modules so that they can all be supervised by the panel, so that they can all send their data to and from the panel. Those are probably the 4 most important terminals on the system, which gets us into terminals 8 through 20. So I don't know if you guys can see right here, but essentially 8 and 9 are for zone 1. Now this zone is special on a Honeywell Vista. Zone 1 is designed to use 2-wire smoke detectors. Now what that means is it puts out a lot more power than the other zone terminals do. It actually pushes power out to power any smoke detectors that you might have attached. And you can have up to 16 2-wire smoke detectors on zone 1 there. It is also the only zone on a Honeywell that requires supervision. And what that means is you have to have a resistor on this zone. Moving on from there, we have terminals 10 and 11. Those are for zone 2. That is the first zone where you can decide whether or not it's going to be supervised by a resistor or whether you want a normally closed or normally open circuit. Now generally, normally open circuits will require a resistor unless it's a specific type of sensor that is normally open. So I'm not going to get too much into that. We have another video that covers normally open, normally closed, and the wiring and all that for that stuff. I'll try to link that down below as well. But essentially, just know that zones 2 through 8 can be set up for either end-of-line supervision or normally closed, normally open circuits. So you get to decide that whenever you're programming the panel, which we do have another video for that as well, so you can check that out if you want to see the programming for end-of-line resistors. Now, zones 3 and 4, they actually share a combined ground, essentially. So terminal 12 would be zone 3, terminal 14 would be zone 4, and then terminal 13 is the shared common for both of those zones. And all that means is they get grounded together. Now, as you'll see in the other video that I mentioned, the more demo style video, polarity doesn't matter. However, if you want to do your wiring properly so that if anybody else comes in and takes a look at the system, they'll know what they're looking at, all zone wiring is going to be yellow and green wiring. Yellow is the powered side, green is the ground. So what I would do for all of these terminals is for zone 12, I would use the yellow wire going to the sensor, and then 13 would be the green coming back from zone 3. 13 would also have the green wire from zone 4 because it is the ground, and then 14 would be my yellow wire. And the whole reason behind that is just so that you can identify things quicker in your panel. So if somebody comes to take a look at it and they're used to working with alarm systems, they're going to know red and black anywhere is your power. Yellow and green is going to be either data wires or it's going to be zone wiring. And as long as you have those separated out properly, you can quickly identify what you're looking for, check for any wiring issues if that is the case, so on and so forth. I've seen an unfortunately large amount of systems that use pretty much all the same color wiring, like And people get like 4-conductor cable that is all blue insulation, so you have a huge amount of blue wires going everywhere in the panel. And yeah, whenever you're first doing it, fine, you know, as long as you know what you're doing, that's fine. But anybody else that comes to look at the system later on is going to be incredibly confused. It's much harder to trace wires that way, the whole bit. So if you can, use red, black, yellow, and green. Sometimes you'll see yellow is white, but make sure you have your red and black for your power for any devices, and then yellow and green or white and green for your data wires or zone wires. So we covered zones 3 and 4. So moving on from there, terminal 15 is for zone 5, terminal 17 is for zone 6, and terminal 16 is their shared common. Same thing for zones 7 and 8. 18 is zone 7, 20 is zone 8, and 19 is their shared common. So the only 2 zones that are different than the rest are zone 1 and 2, and that is because zone 1 has to have its own circuit because it puts out all that power to run those 2-wire smoke detectors. So moving on from the zone wiring, you have an additional 5 terminals here at the end, which are these 5. They do kind of sit on a raised terminal block on the board, so they look a little different than the rest. But essentially those are your phone line wires, and then the last one is an earth ground for the panel. So 21 and 22 are your tip and ring for your handset. 23 and 24 are the tip and ring for the incoming phone line. And then if you're using RJ31, I think is what it is, basically a line interrupter, so that when your panel needs to send a signal out, it can override anything that might be happening on your phone line. You'll connect it to those 4 terminals. If you just have a phone line and you don't actually have like a home phone, you can just connect directly to the tip and ring required to send the signals out. And then 25, like I mentioned, is an earth ground. That just allows you to ground the panel if you want to do it. It's not required by any means, but it can be helpful. One of the biggest reasons alarm systems fail is due to electrical damage from lightning storms or power surges or whatever the case might be. So having that earth ground can help, or it's designed to help. It doesn't always help, but it doesn't hurt to add it if you have the resources. So the only other thing I want to touch on real quick is something I noticed about the other video. Right here in about the middle of the board, you'll see a strip of pins, and those are trigger pins for the onboard outputs of the Honeywell Vista system. Now, in the other video, John attaches a 4-wire smoke detector to those trigger pins because 4-wire smokes require resettable power, and an output is how you set up that resettable power. However, his method, where you use the trigger pins to power your 4-wire smokes, you are limited to like 2, maybe 3 smoke detectors maximum. If you're going to have multiple 4-wire smoke detectors, you do have to use a relay, which there is a little diagram here that talks about addressing relay modules and how you wire them. It also shows the receiver wiring there. Basically, like I said, it's a 4-wire CORBUS connection, so you're going to have your black, red, green, and yellow for terminals 4, 5, 6, and 7. The only other thing you got to do is address them, and then you're good to go. There is also a 4-wire smoke detector diagram here, which shows how to wire 4-wire smokes using either a relay or using the trigger pin there. Like I said, only use the trigger pin if you only have a couple smokes. If you're going to have more than 3, you're guaranteed going to need to use a relay. And the relay modules are the 4229, which is a zone expander with 2 relays included, and then there is also the 4204, which just has 4 relays on it, which gives you 4 different programmable outputs that you can choose from. So that's going to do it for me. That covers pretty much everything you're going to need to know regarding the Honeywell Vista wiring. Like I said, if you just want to see a demo, check below, but if you're interested in this side of it, seeing like the technical aspect of each terminal and what it does, what you can connect to it, so on and so forth, hopefully this was informative to you. And if you guys have any questions, by all means leave a comment down below. If you're interested in any Vista equipment, check us out at alarmsystemstore.com. We have the Vista line and all the required modules that I have mentioned in this video. And if you're on YouTube, give a comment and leave a like and subscribe if you don't mind. All right, I will catch you guys on the next one.